It wasn't really a planned talk, so forgive the off-the-cuff slides that I wrote like a couple hours ago. But I figured it was probably worth talking about a bit of the stuff that I've been working on and a bit of the stuff that I'm like either going to be working on or I'm particularly excited to see that I know is being worked on for next year. It's a bit of a brain dump, so apologies in advance for the lack of structure and general plainness, but hopefully the content will be interesting. So there's three sections. First one is, the past, what I've been working on, what I've been working with other people, what I've been keeping an eye on, and particularly the stuff that's been taking my time for like the last 12 months or so. Some of this stuff, I guess, many of you will already know, like 2D weights. This is like a fairly substantial, fundamental change to how Substrate works, particularly for parachains. Some of the other stuff maybe is going to be a little more interesting that you won't already know. So 2D weights, in case you're not familiar with what this is, weight is a means of specifying the level of the amount of resources that a particular function, generally block import or transaction import, is allowed to use. Usually it's, in the past, weights were one-dimensional, which is the scalar value, the amount of computation time we expect a particular operation to take. These days, we have two separate resources. We have both the execution time, but we also have the amount of space inside the proof of validity. Basically the proof that the parachain submits to the relay chain, that the relay chain can check and make sure that the collator is not telling fibs, is not cheating the system. Now the problem is that if you have a transaction, it may take not very much time, but it may end up having a huge footprint inside of this proof of validity, this data chunk that has to go to the validator. And this is this can open up your parachain to DOS attacks. Worse, if this happens as part of like a mandatory function for block import, like for example on initialize as part of the scheduler, or maybe as part of executing XCMs, incoming XCM, then you've got a big problem, because it would mean that you're doing something which you can't opt out of doing, which is going to make your block unimportable because the proof of validity is just too big. So this is like crucial for parachain security. The way we're doing it at the moment is we're basically fudging it. We've got some very, very conservative limits that restrict what XCM can do, that restrict the amount of XCMs that can be executed, and we're kind of just really not using scheduler too much in order to reduce the chance that a mandatorily scheduled operation would bloat this proof of validity block too much. Actually, the newer scheduler does take into account the 2D weights, and over time, while we move things over to this new two-dimensional weights data type, we'll have all of the operations that can be scheduled, all the dispatchables, actually reporting their weight correctly. But this is like a fairly big, hefty refactor. It's probably going to be finished, I would hope, in the next month or two. But it is rolling along. Message queues are an update to XCMP, UMP, DMP, effectively needed because of the 2D weights refactoring. Essentially, it's functionality deficit that we needed to move, but it's kind of nice the way it's architected now. There's a unified message queue that works for all of the potential origins that messages can come from, whether it's from another parachain, whether it's from the relay chain, whether it's from the local parachain itself. whether it's maybe from the contract environment. It's all unified, they go into the same queue, and it's got a nice kind of round-robin thing going on, so you've got a bit of quality of service guarantees, and it's 2D weight compatible. Something that's been on the sort of boiling away, simmering away for a while now is XCM v3. It's got a bunch of stuff in it that people are going to find useful. It enables a bunch of stuff, not least bridges. So super keen on getting XCM v3 merged. We're on the kind of final, I don't know, 4 relatively minor bullet points before we actually merge it. It has undergone an audit, so we're reasonably confident on that regard that we at least know any issues that are coming. But some of the other things, like for example, message queues and 2D weights, kind of need to be done before we can unlock all of the XCM v3 functionality. One of the big things that has happened recently was, as I would hope most people here are aware, is Gov2 or OpenGov, as it's recently been termed, launched on Kusama, and we're seeing some of the first referendums happening under this new logic. OpenGov is pretty cool. I don't know how much you sort of looked into it. Basically, it's several abstractions that allow you to build democratic bodies which can be composed in order to create these kind of sophisticated governance structures, but similarly very agile. The agility comes from the fact that you can effectively introduce many different origins. So many, like I mean origin in the technical term, dispatchable origins, each of which can have different effective privileges. And with each of these different origins, you can attach a different sort of democratic or governance requirement for calls from these origins to be made. So obviously there's the root origin, which would have the most stringent requirements. Then you can have like the tip origin, right? Which doesn't need to have very strong requirements at all. Why? Well, because the downside, the possible worst case that you can do if you can somehow manufacture access from this origin is spend a very small amount of the Treasury's funds, right? So this allows you to create really quite sophisticated governance models. And I found a new term a few days ago, like optimistic voting. It's basically like you kind of allow one particular party to have to be able to dictate how a vote will go. Basically, they will be able to push forward a vote unless other parties actually say no. And this allows you to vote on the thing, or allows you to sort of fight out the things that are controversial, but get the things that aren't controversial through relatively quickly. As you might be aware at the moment, we have 28 days per referendum and only one referendum at once, accepting fast tracking on Polkadot. And it makes things very difficult to get through, and because everything has to get through on this same pipeline, a lot of things basically fall by the wayside. Well, that's no more with OpenGov. One of the things that we sort of aiming to do with OpenGov is allow free delegation, because OpenGov removes some of these bodies like the technical committee and the council. One of the things that we want to do is introduce free delegation. Delegation is effectively this way of like having kind of representatives, so you don't have to like vote yourself necessarily. But we want to get as many people delegating as possible, and this is hard if it costs money, because most people, don't want to pay money in order to just have a voice. Most people are not, it turns out, all that bothered about having a voice in these referendums. But the assumption is that if it's free and easy, maybe we get a lot more people on board. One of the things that is introduced as part of OpenGov is the fellowship palette, which I suspect probably a few of you are aware of at least. In some sense, this fulfills one of the usage roles of the technical committee, but it's a lot more pluralistic, and it turns out it's a lot more agile as well. And the way that it's been written is to allow it to be reused for all sorts of other groups that we may want to have on-chain formations of. The Fellowship Pallet itself is for experts on Polkadot's core technology. There's a fairly substantial white paper that sort of explains the social elements of this on-chain structure. One of the sort of key things to understand about it is it's a membership-oriented thing, so it's an on-chain collective that has a bunch of members, but each of these members has a rank. Yeah, and the rank goes from basically 1 to 9. And there are rules, socially enforced rules, some of them at least. Some can be on-chain enforced, but the more rich ones are socially enforced. And these are the rules for getting promoted up through the ranks. It's loosely based on martial arts ranking systems, and one of the ways that it's useful. There's a few ways that it's useful. One of them is to provide recognition for those experts in the Polkadot protocol. And in doing so, help safeguard Polkadot's, the body that contains Polkadot's expertise. Another one is to serve as the technical oracle for governance, right? So it's actually a governance body, it can be used in that way. And another one is to provide incentivization for actually bothering to become a Polkadot expert and to retain that expertise. And there are benefits accordingly for being within the body, and the hope is that eventually companies that employ individuals who have core expertise on Polkadot and try and incentivize them to carry on doing that work won't strictly be needed, because the chain will be able to build that incentivization structure itself. Now then. One of the most recent things that was finished is actually all green, it's ready to merge, hurrah, is the NIS pallet. NIS stands for non-interactive staking. It's let's say a different form of staking, very different to staking. But staking seems to be used for a lot of different things these days, so I decided to introduce a new meaning of the word. This is essentially it offers holders of a token, particularly if the token is subject to inflation, to its monetary-based inflation. It offers the possibility of gaining a resistance to that inflation. Now you might say, well, hold on, we already have staking. That offers resistance to inflation as well. Actually, staking is a little different. Staking is more of a quid pro quo. You offer to help Polkadot maintain itself securely, and you get beyond inflation reward, right? So, let's say 50% of the token base is held in inflation. Well, if the overall, is held in staking. If the overall inflation rate is 10%, then in principle, you're going to get up to 20% rewards, right? But 10% after taking into account inflation. Well, this offers basically 0% after being taken into account inflation, but the nice thing is, you don't have to do anything. The way the underlying way that it works, you get a receipt, so you put sort of stake using NIS, some tokens, you get a receipt back, right, that says your tokens constituted 0.01% of the network when you put them in. You can take this receipt back. This receipt's an NFT, right? You can transfer it around, and you can take it back to the NIS system. So after some point in time, the deal is that you can't do it until some point in time, but after some point in time, you can take it back, and you can get your original, you can get an amount of tokens back such that the percentage of total issuance is the same, right? Now, the interesting thing is that in addition to the NFT, there's also a counterpart receipt, which is fungible. And it's based upon a particular upper amount of tokens, some amount of tokens that represents 100% of the network, 100% of market cap, right? So you get your 0.01% NFT, but you would also get 0.01% of fungible tokens as well. Yeah? And the idea is that you have to provide them both to get the original, to trade them back in for the original percentage corrected tokens. These counterpart tokens can in principle just be moved around arbitrarily. They're fungible with each other. This opens up a new asset. It opens up an asset which, when combined with an appropriate receipt, can be tradable for a percentage of the overall market cap of a particular token. More on this later. So, second section, some of the stuff that's already been completed but needs reforming, refactoring. This is some of the stuff I'm excited about or I'm working on. Polkadot Academy started last year in Cambridge, UK, not the one in Massachusetts. I did a bit of teaching there. We got through, I think, a little over 50 students, and we taught them basically boot camp in everything decentralized, crypto economic, Polkadot, Substrate, even finishing with XCM. General outcome was very good. A lot of people were very happy. Anyone here who went to that, by the way? Quite a few. Very good. 5, 6, 7. So this is this is looking like it is going the way that it was originally envisioned, and as such, we're going to start a new intake early next year, January the 8th, if my memory serves, in Buenos Aires this time, south of the border. And the idea is that we'll probably have minimum 75, but probably closer to 100 students. And yeah, I'll be helping out again. I'll be teaching a bit of crypto and stuff. One of the other things that I think is, this is more like refactoring, I suppose. Ecosystem standardization. There's a few ways to go in this, but I think it sort of needs, I've highlighted 3 here. There are for sure more, but these are the 3 that I think are relatively easy to do. XCM configuration is a bit of a pain, I think, for many parachains. It's quite complex. It reflects the early stage and the rather changing sort of environment in which XCM sits. But I think we can reasonably offer a fairly standardized XCM template configuration that can be tweaked perhaps for each chain, but in principle can reduce a lot of the tedium and risk from parachains. XCM weights, at the moment it's a bit of a pain when you're sending a message to another chain to like try and calculate what the what weight should be provided and therefore what fees should be given and paid. I think it's not unreasonable to have some fairly standardized weights so that this basically isn't a problem. We just take reasonable to worst case kind of expectations, round it up, and it's like weigh it yourself, but as long as your weights don't come in beyond the standardized weights, you're basically safe just to have standardized weights. You can put a little banner up. This parachain uses standardized weights, and all of the other parachains that want to send messages know that they can just work out what the standardized weight is for this message to be executed, and they don't have to bother about trying to figure out what your particular parachain's weight actually is. And transaction priority, I've seen in the past we've actually had multiple what they call like transaction extensions that are like trying to work out what the units for transaction priority are. We haven't really set any, and I think it may be time to like consider this. It's especially useful for things that are wrapping exotic kinds of transactions, like some of the EVM based chains. And at that point, I think this kind of thing is useful. There are I don't want to try and suggest that I'm like all of the other levels of ecosystem standardizations are not as important as these. These are just the ones that I think can be done in a matter of weeks rather than months and months. One of the things that constantly comes up is weights and how difficult weights are, how tedious they are. I know, particularly benchmarking, like weights themselves, they're whatever, but like benchmarking, very tedious, kind of error prone. I've written quite a few benchmarks myself. I'm well aware of this. Now, benchmarks are basically strictly necessary if you want to have the best possible efficiency. But a lot of the time, the best possible efficiency isn't actually that important. You just want to get something that works, and you're willing to put up with like 80 or 90% efficiency. One of the things that I think we'll really try and push out through 2023 is this concept of weight clawback, which is basically saying, I'll give you an overestimate for how much weight this operation is going to take. Like, it won't take any more than whatever, X. But in reality, it's probably going to take X minus Y, right? And Y could be fairly substantial. The crucial thing is, after the operation is completed, that we can check how much weight did it actually take and update our bookkeeping accordingly. Yeah? If we can do that, then suddenly Y can be really quite large, and the only thing we're really missing is the ability to squeeze in that last transactions into that last little bit of block space. We could, for example, say, well, we don't know exactly how much weight this particular operation takes, but we know it's definitely no more than 10% of the block space. Yeah? Now, this means that even if you've got a block composed entirely of this particular transaction, you'll still be able to get 90% of the block full before eventually you get like a little over 90 and you suddenly think, well, I can't take the risk that it would actually take 10%. This is probably going to be the strategy for trying to reduce the need for teams to write these fairly, sophisticated benchmarking code. Of course, for operations that actually can take upwards of 10% of the block space, depending on the state or the inputs to the transaction, to the operation, then yeah, that's a bit different, and you actually do have to bother writing the benchmark. But for everything else, especially like relatively small, trivial things that are strictly limited in how much weight they can actually use up, this should be pretty much fine for a lot of teams. The relay chain was never meant to enclose so much functionality. Yeah. It's really there just to secure it. In fact, calling it a relay chain, it always niggled me a bit. In reality, it should be the security chain, because it's, at least when XCMP is properly finished, it won't really relay anything. All it will really be doing is making sure that parachains are running securely. In any case, it's only meant to be validating. It's not meant to be like hosting tokens. It's not meant to be hosting the staking code. It's not meant to be hosting votes. It's not meant to be hosting a name registration system. These are all things that fit perfectly well into parachains, yeah? That can actually do real computation, but in a parallelized way. So, we need to start offloading some of this functionality that has ended up on the relay chain, just because we didn't have anywhere else to roll it out to, and offload it into parachains. And that's something that, we'll be focusing on. I think it's pretty exciting to think about for next year. So we've already started this, we've got statement. So there is assets functionality already on a parachain and there's a system chain. But, bridges, that was something that we could have rolled out sooner and rolled it out directly to the relay chain, but instead we held off a bit in order to actually get it into the parachain from the get-go, because moving it would be an absolute pain. There is already a collectives system chain. And governance will slowly be being migrated onto there, as well as some of the fellowships. Staking is an interesting one, but already starting to think about what's necessary for that to happen. And you know, one of the chains that we haven't sort of talked about so much, at the moment the Relay chain is hosting name registration, which is effectively a form of authenticity and certification. It would be nice to abstract that out a little bit and have it on its own chain. All right, so that's sort of the stuff that has largely been started or is being finished up. Now some of the stuff that's like legitimately sort of new. The state tree, Polkadot's state tree, was in some sense designed around the Ethereum state tree. Right? Both are Merkle trees. If you look at how it's implemented, they kind of have a fairly similar design. There was a lot of tweaks. We switched, for example, the serialization format. We removed one of the types of tree nodes. But at the end of the day, the underlying implementation are fairly similar. Crucially, what is persisted on the underlying disk is a Merkleized structure, right? It's actual crypto nodes, right? It's like it's chunks of data that form a Merkle tree. Yeah, it's not the keys and values themselves. So when you store in Substrate something in a map, in a storage map in your Pallet, or you put some store some bit of data somewhere in a key. This value directly doesn't correspond to any particular key or value in the database. In reality, it corresponds to kind of a number of different keys and values that make up the root with a U, R-O-U-T, from the root without a U, down to the leaf. This is fine, it's general, right? It works. You can implement what you want to implement. Yeah? If you want a value that only stays around for the period of the block, like for example, we record the block number. Yeah? This is a value that we only, it's actually held in storage, but it gets deleted at the end of the block and it gets put in at the beginning of the block. Some of the header data is the same, right? It gets put in at the beginning of the block, it gets deleted at the end of the block. You can implement it using this, you just make sure it gets deleted, right? Sorted. But it's not as fast as it could be, because when you try and read it, it has to do something clever, like go and check in its disk-backed bit whether there's something there already. There are other things like events are a bit of a pain. They take up a single storage item that just gets appended to. And at the moment there's no way to tell Substrate that they never get read from. Which means in principle, you've got this kind of huge potentially huge unbounded storage item that might make its way into the proof of validity of a parachain, and therefore make the proof of validity really, really big. And if someone accidentally did write code that read it, it would be a big problem. Furthermore, there are certain queries and processing that you might want to do on events that essentially now are unbounded. They're not in a useful format for this. And it doesn't really let you do interesting stuff, like, for example, as part of block processing, create ways of indexing certain events. So you might have an event like, balance transfer, and you just want to know, you want an index so you can easily prove this account did or did not make a balance transfer in this block. Well, you can't really do that at the moment. You just have to list all of the events that happened, and then go through them all and show that none of them implied a balance transfer from this account to that account. That's not very efficient, particularly for light clients. And some of the stuff that we want to do in the future that would be massive potentially, optimizations for Substrate, for parachains, for Polkadot, you just can't do with this kind of data structure. You need a lot more flexibility. You need the possibility of having an entirely arbitrary, basically, data structure given a key value, given a map of key value pairs. I'm not going to go too much into this at this stage because it would take a really long time, but suffice it to say, what we're going to try and do, there's already an issue, is implement some new host functions that allow for all of these things to happen super efficiently. Statement Holding Hub Protocol, or SHH protocol. Accounts. This is similar to Whisper. You know, I don't know whenever that was, 7 years ago, 8 years ago, long time ago. It's similar to Whisper. The only difference is that whereas Whisper didn't really have an answer to any kind of denial of service attack, this kind of does, because it's only accounts that are holding funds that are able to actually send post messages to this massive global DHT. That's essentially what this is, a massive global DHT. The idea being that off-chain workers can kind of subscribe to pigeonholes in this massive global DHT and be told when something new has been posted by an account. The nice thing is that posting a datagram to this massive global DHT doesn't cost anything, right? Because you're not touching the chain. So this means that you can have, it opens up the possibility of having, for example, free delegation. Because these things can be signed statements, you can basically say, I will sign, I reckon Raul Romanuti is a great voter and he knows exactly what's going on with Polkadot all the time. Therefore, I'm going to delegate some of my accounts, the funds in my accounts, to vote for him. But here's the thing, I don't want to pay anything, yeah? I'm just going to delegate. I'm just going to say, I'm giving him permission to claim this delegation. It's just a statement. It's signed, but it doesn't equate to any kind of transaction, yeah? No funds are ever going to go out of my account because I've signed this statement. But what it does is it means that Raul can come along and say, ooh, someone has delegated their voting power to me. And Raul can go and pay the funds, include this signed statement on chain, and then the chain will then run the delegation and he will be delegated. I never had to pay any money, but only Raul does it. It's an opt-in for Raul. If he says, well, this guy hasn't got enough dot to make it worth my while, then he'll just ignore the statement. So this is the sort of thing that opens up, but there's like a whole host of other stuff, I am sure, that you might be able to think of as well. One of the things that's been talked about for a long time, parathreads. This has now become a more abstract form of itself, exotic core scheduling, exotic para-core scheduling, basically opening up new scheduling mechanisms for these para-chain cores. At the moment, we've only got these 2-year leases. This is like, fairly difficult, or fairly, I don't know what you call it, abstruse way of working out what computation should be checked by the relay chain. So we want to open up and like create a much more, a much wider spectrum of ways of utilizing Polkadot's block space. This is what it comes down to, right? This is the new way of thinking. Polkadot has a bunch of high quality block space, probably the highest quality, most of the highest quality block space out there, right? It's got a huge amount of high quality block space. And the question is, how do we parcel it up and sell it off and make sure that the DOT token benefits, like there is a useful economy around this block space. And as it stands, the PLOs and with the crowd loans are like just one first step. And there needs to be many more steps, and one of the ways to unlock these many more steps are exotic core scheduling. So this is something that we're like, is being worked on, something that I'm very excited to see. Parathreads, which is basically pay-as-you-go, block by block Scheduling would be one of the ways. There are several other economic scheduling mechanisms that we can think of. Round robin being, so basically n parachains can share the same kind of lease. But we can also think of like short-term, but not really short-term leases. Like, I don't know, 2-week leases, 1-week leases. Yeah? You just pay, kind of pay as you go, somewhere between power threads and parachains. One of the, you already saw the fellowship launched last week. Maybe it was the week before, last couple of weeks. It's only meant to be the first of its kind. There are several others that I want to launch. Probably the first one to launch, the next one to launch, will be the Ecosystem Technical Fellowship. So all the people that are, building with Polkadot that have, not knowledge of the core, maybe knowledge of the core protocol too, but not just knowledge of the core protocol, but knowledge of how to use Polkadot, how to build on Polkadot, knowledge of the peripheral tools and services, how to build a parachain, how to deploy a parachain, all of this stuff. It'll have similar sort of mid-level goals as the first fellowship. Recognition of expertise being one of the crucial ones, but potentially also an eventual role in governance. And one of the things that I can immediately think of, parachains, not often, thankfully, but sometimes come to the technical committee, say, oh, we bricked it, it happened, it happens. Can you switch things over? Can we get a fast-tracked referendum? Now, this will be partially fixed in Gov2 anyway, simply because of the fact it will be a different origin that is required, one that can be executed much more optimistically. But even ignoring that, hey, it could be that the Ecosystem Tech Fellowship itself is a democratic body that can vote in order to essentially unbrick a parachain, rescue it, move it back to a previous state, whatever. This is, in my mind, how a lot of this stuff should be solved. Basically, by moving things closer to a body that could reasonably be considered expert enough, but also decentralized and diverse enough to make sure stuff doesn't just get broken more. Okay, that's it, yeah. Final thing, Polkadot Payroll. This is another one of these governance structures. I mean, when I say governance, I get the impression I'm talking about what a lot of people mean when they say DAO. But whatever, I'm going to stick with my original terminology. But this is another governance structure. Think of this as like the Polkadot civil service. Essentially a broad on-ramp, right? A way of trying to recognize valuable contributions, like when someone is doing consistent valuable contributions, and ensure that they have consistent income from it. In some sense, it's here to try to mitigate or even really reduce the level of need that Polkadot has on some of the bigger organizations in the space, not least Parity and the Foundation. The idea is to make it really very much an on-ramp, permissionless entry, minimal requirements check, basically just, are you a reasonable bet? Yeah? Are you reasonably likely to actually do anything in 2 weeks? Think something like, I don't know, a CV, yeah? You've been to a course like, I don't know, the Polkadot Academy, right? You've already done some pull requests, I don't know, something very basic that is easily checkable and just make sure, yeah, you may well actually do something useful for And you get a proving period, a couple of weeks, right, to actually do something. If you do something, checked by probably the fellowship, maybe the ecosystem tech fellowship for technical individuals, right? If that comes through and they say, yeah, you've been doing a fairly decent amount of work, eventually, maybe let's say after 5 work periods, you basically make your way into the payroll and you become a payrolled accountant. And the idea is that this can be the on-ramp into fellowships. Not necessarily just the fellowship, the first one, but also other fellowships. An ambassadorial fellowship, for example. Ecosystem Tech Fellowship. There's a much more detailed design document that's gathering dust, but this will be, as I say, something to look out for in 2023. Good. That's all I have to say for now. I hope it was a bit enlightening at least. Thanks, and do enjoy Sub-Zero.